Hi everybody, this is Mrs. Elefante of Science Simply Explained by Ivy Elefante. As you can see, we have a new channel, and yes, I did separate my science lessons and tutorials for you guys. So although we already have many subscribers in our other channel, but I encourage you to please go ahead and support this channel by clicking the subscribe button down below so that we can upload more videos and tutorials that will help you complete your portfolio, especially because here in this channel we are going to explain how to complete the portfolios in Edgenuity, and as well as I'll be adding more content videos about our lessons which will help you understand more the topics, especially complete your quizzes and tests with flying colors. So there you go. Please, if you are new here, welcome and subscribe to this channel and click the notification bell so you'll be notified of our upcoming videos. So for today's video, we are going to explain the kinetic energy lab, which looks like this. And where to find this is, you go to your lesson, of course, and it is Unit 1, Lesson number 7, which says Lab Kinetic Energy. And you are going to, of course, do the warm-up, the instructions, the virtual lab, which we're going to explain, and you're going to reflect on the lab, and then the summary. And here is your student guide. In a bit, I'm gonna show you how we access our student guide aside from accessing it here from Edgenuity, because I have uploaded everything in your message board. So before we go ahead and explain the lab, let's just review real quick about kinetic energy. So the equation for kinetic energy would be just, you have Ke is equal to 1/2 mv squared, and our m here stands for mass, and it must be in kilograms. So if the mass is given in grams, so just know that 1,000 gram is equal to 1 kilogram, because kilo means 1,000. Okay, so in other words, if you have, let's say for example, what is given is 500 grams. So what you're going to do is just divide it by 1,000 times 1 kilogram. So you can cancel the same units, which is gram, and what we have remaining is kilogram. So 500 divided by 1,000, and it would be 0.5 kilogram. Without using the calculator, you can also get 0.5. Here you have 2 zeros on top and 3 actually zeros at the bottom, but what we have is we just cancel this zeros, and then what we have remaining is just 1 0. So what you're gonna do, 1 0 means 1 decimal place, so that's why we have here 0.05, which is 1 decimal place kilogram. So another variable here is V, which stands for speed, and speed is just meter per second. And in this lab, we are going to see the effect of changing the mass, either increasing the mass or increasing the velocity. What is the effect of these changes to the kinetic energy of the object? Will the kinetic energy increase or decrease? So if you open the lab, you will be directed to another tab, which looks like this.
Here we are at the lab. In this,
so definitely this boxes right here, you are going to go over one by one. So this video tutorial is intended for explanation on how you answer the table. I will not give all the answers, obviously, but I'm just going to give an example for you to complete. And let's go ahead and access the student guide. So if you open the student guide right here, you have a Word document which looks like this. I'm going to click enable editing, so you'll be able to write answers there. And as you can see, it's quite long, but these steps are already you can read it from the guide, and this is table A and table B. But that's not everything, because there are pre-lab questions and post-lab questions along with this one, which you are going to download from another link. So what I did is I posted it on the message board. This portion is intended for those new students, so just bear with me real quick. So when you open your message board, go ahead and click on Physical Science B, and then you are going to open Portfolio Instructions, And as you can see here, I have a kinetic energy lab. So we will have more lists as we go. So for this semester, you are going to have 2 projects. and 3 portfolios, your labs. So you're going to open that, and here's the sticky note which you are going to download, and when you open it, it looks like this. Click enable editing so you can type something on it. And here's your name, date submitted, and here are the pre-lab questions which you are going to answer. So we have here 3 questions for the pre-lab, and you refer your answers from the information here on top, especially for the hypothesis and the questions that we are going to answer for this lab. And then these are just prompt questions. So you are going to write a paragraph to answer these questions. Here we have our data table, table A. I'm going to explain this part only, and table B, only the first part, but not everything, just an example. And by the way, guys, for this observation, you are going to make an observation from here. Later, I'm going to explain which question are you going to answer to complete the observations. And then the same thing for data and observation. You are going to answer questions 4 and 5 in a paragraph form, and number 6, 7, 8 in a paragraph form. And here in graph, this is just a sample graph that I posted here, or I pasted here. Definitely you can remove this and create your own graph. So you can go ahead and put insert, and then you have chart if you want to use chart like a bar graph, and you also can use different types of graph using Excel. If you want me to teach you how to create graph, let me know in the comment section below so I can have another video tutorial on how to create graph using Word document or Excel. And then the post-lab questions for summary and conclusions in a paragraph form as well. And that will complete your lab report, and this is 100% of your grade. And the questions will be 30%, and the data table will be 70% of your grade. Let's begin. So suppose that you already have watched and listened.
Here are the materials you'll use in this virtual lab.
So here are your materials, and then you're going to click the student guide again. I think you will be prompted to the same document and probably another question. So yeah, my suggestion is just go right away to the message board and download the document. So obviously this is a drag and drop, so you don't need to buy the supplies. It's a virtual lab, so we're just gonna go ahead and click yes and done.
Be sure to follow along.
So here you're just going to set it up so you will know how it is set up. So we're just going to do it real quick. So here, this is how we set it up. We're just going to divide this part into 2, just like creating a lever, and then mark where we can put the beanbag and the water bottle. So kind of we are going to measure the mass and the velocity and the kinetic energy of the object, which is the beanbag. So that's how the setup would look like, and you're just going to click the bottle or tap the bottle, so we will have a height of the beanbag measured. Alright, so for step 3, we are going to calculate the predicted change in kinetic energy, which is this part of the table, column 3 for table A. And it says here, calculate the change of kinetic energy of the bottle when the mass is increased. So right here, we are actually changing the mass. As you can see, we have a 0.10125 until 0.5 kilograms. So we are going to see what is the effect here in the kinetic energy with the increase of mass. So I already have introduced to you this equation. So mass is m and v is your speed. And assume that the speed of the soda bottle falling from a height of 0.8 will be 4 meters per second. So we already have a standard that is presented to us here, which is our speed of 4 meters per second. So what we're going to do here is solve for it, obviously. Speed is 4 meters per second. And the height was 0.8 meters. And of course, our equation is KE is equal to 1/2 mv squared. So our mass is this. This is our mass. So how we are going to solve for kinetic energy. So our velocity here is already given, by the way. So we are going to write here 4. You don't need to write the unit because it's already up there. So that's 4. So it's consistent. So it will be 4 for all of these. Okay. So I'm just not gonna write that because I want you to do that. All right. So right here it says 1/2, and our first mass is 0.125 kilogram, and then our speed was 4 meters per second squared. If you are comfortable using 0.5 instead of 1/2, that's okay. And then 0.125, and then 4 squared is 16. So do the equation, the exponent first, and then you are going to multiply the parenthesis. So it's going to be, and then 0.5 times 2, that means half of 2 is just equal to 1. So our kinetic energy is 1 kilogram meter squared in second squared. So our answer right here is 1 kilogram meter squared second squared. So that's how you answer, and then you are going to choose your answer here, and that would be 1. And then you put the answer here. So basically you're going to do the same thing here, and just know that the mass is changed. So it's increasing. So what do you think is, what's your prediction to the kinetic energy? So once you finish that, just go ahead and go to the next page. And then here we are going to observe the changes in mass of the bottle. Observe the changes in the mass of the bottle and how it affects the height of the beanbag. So you're going to want to drag this bottle. Just click continue. And you're going to drag this bottle to the sink. And then we're actually trying to take out some water for us to get the mass of 0.125. So that's that. And then just click continue. So what you're going to do here, it says have the bottle so that it can be dropped from a height of 0.8 meters. So you're just going to do that. And then it will give you the measurement of 0.36. So you're going to want to write that. And then just click on continue. Of course, we always do 3 trials so we will avoid bias. So click on continue and then do the same thing, and you will have here 0.37. So yes, that's how you do part A. And of course, you're just going to get the average height of the beanbag, add all 3 divided by 3. And that's how you do table A. For your observation, you are going to answer this question. Here, you are going to calculate for this. When the mass of the bottle is 0.125, the average maximum height of the beanbag is, and then you're just going to choose your answer here. You're going to add all 3 and divide it by 3, and whatever answer you have there, you have to click it here before you click on done. And then let's go ahead and proceed to the next one. Make an observation about the average height of the beanbag for each mass dropped. How does it compare with your calculating energy? And so you are going to answer that question here. I'm just pasting the question so you know what question to answer here. You don't need to paste it, but if you want, then go ahead and then just add your answer. But this is the question that you are going to answer. I will highlight that. We are going to go ahead and do letter B or table B. This time we are changing the velocity of the bottle. So notice for table A, we changed the mass. We were increasing the mass, and you are going to find out what is the effect on that to our kinetic energy. But table B, we are increasing the velocity, and we are going to find out what is the effect of that in the kinetic energy. But take note here, guys. This table or this column right here says estimated. That means you can have a whole number, which is an estimate. So you don't need to put the decimal number there. All right. So it says here, you will use the same mass, which is 2.50 kilogram. So here is 0.250 kilogram. So technically that will be the same for all of these because we are keeping our mass constant here. So it's constant. It will not change. On the other hand, above is we are keeping the velocity constant. So again, increasing the mass here, making the velocity constant, what is the effect of that to our kinetic energy? For this one, we are increasing the velocity, maintaining or keeping the mass constant, and what is the effect of that to the kinetic energy? So what you're going to do here, of course, the same thing. You are going to use the same equation, but this time you are going to use this velocity 2, 3, 4, 5, 6, maintaining the mass of 0.025. So let's gonna have an example for the first one. Kinetic energy is equal to 1/2 mv squared. Constant value that we have here is our mass, which is 0.250 kilograms. So that would be the same for all of it. And then our velocity is depending on what we have here. We have 2, 3, 4. So let's say we are going to do the first one, which is 2 meters per second. So what we have is kinetic energy is equal to 1/2, and then our mass maintains at 250 kilogram times 2 squared. Okay, so that's going to be 0.5. If it's easier for you to use 0.5, that's fine. Times 4, because 2 times 2 or 2 squared is just equal to 4. And then you are going, I'm just going to show you 2 one by one. So that's going to be 0.250 times 4 would be equal to just 1. All right, and then it will be just 0.5. So it says estimate. What is the estimate for 0.5? Put 0.5 right there and see if you have a 0.5 here. And yeah, we have a 0.5. Okay, and then you are going to put 0.5 here. And then you're going to do the same thing for 3, 4, 5. So you're just going to change this number to 3, 4, and 5, and 6 respectively. So for us to answer this, you're going to want to do the same thing. So just drag and drop and then get the measurement. So that's 0.250 and 0.250 is for here. That's our constant mass. And then just going to click continue. And then here, height to drop the bottle. It says here 0.2. So you're going to want to put 0.2 right there. And then click on the bottle and then it will give you the height, which is 0.1. So actually this lab is not difficult, so you just need to follow all instructions. The point is you know what equation to use and what numbers to put in the to replace the variables with. Okay, so same thing, same height is 0.2, and then you have here 0.11, and then of course get the average 0.1, 0.1, 0.11 divided by 3, divided by 3, and then you're just gonna want to continue. For this one it's 0.46. So yes, that's how you finish this lab. And then here you are going to get all the averages and put the number here. Say you got X, so here you're just gonna choose which one is X. Okay, and then click on done. And then here is your observation part. You are going to answer this question. How does it compare with your calculated kinetic energy? So here, for example, just an example, you got here 0.75. So you cannot estimate it to just 1. So you're just going to want to put 1. And how does it compare with your calculated kinetic energies for each speed? So for each of the speed, which is this, how are you going to compare their kinetic energies? Did they, with the increase of speed, did the kinetic energy increase or decrease? Okay, and then after you complete everything, and then you're going to answer this data on observation, your analysis, and of course your graph. So like I said, if you want me to do a tutorial on how to create a graph based on your data, let me know in the comment section below. And then finish your summary and conclusion. So that's it, guys. I hope this video has been helpful. And like I said, if this is helpful for you, please give this a thumbs up and subscribe to this channel and click the notification bell so you'll be notified of our upcoming videos. Again, please support this channel so I can support you as well. Thank you very much and God bless you all. Bye.